Okay, we're going to have a brief discussion about what's called Newton's second law. This says that when you have either one force or many forces acting on an object, you can use those forces to determine the way that the object moves. Physics is the study of forces and how they cause or impede motion. So forces as a concept are extremely important in physics. It's important that you understand how this works. The reasoning behind it is actually really, really simple though, because check this out. The harder you push on something, the faster it will go, right? This is totally obvious. If you have an object of a certain set mass, like 10 kilograms, and you push on it with a certain force, the harder you push, like say that you double that force, it makes sense that the quickness with which the thing moves will double. So the harder you push on something, the faster it will go. That is the concept of force and acceleration being directly proportional. So now this also says for a constant force, mass and acceleration are inversely proportional. Well, what does that mean? So let's think about what happens when you have a constant force, say like, a 50 Newton force that you're pushing on something with, but you push on two different objects with that. The same push applied to a heavier object will move it less. Applied to a lighter object, it will move it more. Once again, this is no fancy calculations or formulas or anything like that. We're just going for proportionality. If for an object of a given mass, you push with a certain force, it's going to move it with a certain acceleration. But if that same force is applied to something with a lesser mass, then that force is going to be more effective at moving that thing. And so that's why for a given constant force, mass and acceleration are inversely proportional. Inversely proportional means when one goes up, the other goes down. More mass, less acceleration. However, more acceleration means that you must be moving something with a smaller mass. So that's what's called inversely proportional. And we've shown number 2 as well. Keep in mind, whenever you come up with a new quantity in science, you need a unit to describe that quantity. We've got kilograms for mass. We've got meters per second squared for acceleration. Now, force has its own unit. Force is measured in newtons. And a newton is what's called a derived unit in science. It is 1 Newton is equal to 1 kilogram meter per second squared. Now, why is that true? It's because if force equals mass times acceleration, think about the units of these things. Mass is in kilograms, acceleration is in meters per second squared. When you multiply those together, then this must be a kilogram meter per second squared. This just gets called a Newton. The reason you use Newtons is to determine accelerations, which in turn determine all the neat kinematics things that we've been talking about so far. So now we're about to go through a couple problems in the subsequent videos on how you actually apply this. We're going to go both for the determination of forces and ultimately for the determination of accelerations. It's going to be fun.